Welcome to The Explainer, where we break down complex topics into clear, engaging explainers.
Okay, let's just dive right in. Take a good look at this thing. It might look like some kind of weird plumbing experiment, maybe some abstract art, but what you're actually looking at is a computer. A computer from 1949 that's over 2 meters tall and used flowing water to model the entire economy of a country. I mean, seriously, could you do that? Back in the 1940s, one man was absolutely convinced you could, and he went ahead and built this incredible machine to prove it. This is the story of the MONIAC, a machine that turned abstract economic theory into a living, breathing, flowing system right before your eyes. So, to really wrap our heads around this bizarre machine, we first have to get to know the incredible guy who invented it. His name was Bill Phillips. And let me tell you, he was not your typical stuffy academic economist. Not even close. This was a man of action, whose life story honestly reads more like an adventure novel. What's so wild here is how all these completely different parts of his life came together in this one invention. You see, his time as a POW building a secret radio out of scraps, that gave him this amazing talent for improvisation. And his engineering background, well, that gave him the technical chops. For him, this wasn't just some academic puzzle. His hands-on experience meant he saw complex systems not as boring equations on a page, but as physical, tangible things you could build and tweak. And what's funny is that a fellow prisoner of war described him as this quiet, humble guy, which is such a huge contrast to the wildly imaginative, show-stopping machine he would end up building. He was this quiet genius who figured out how to use his engineering skills to make the invisible flow of money visible to everyone. Okay, so the big question, how on earth does this contraption of tubes and tanks actually work? Well, Phillips's whole invention was built on a simple but totally brilliant analogy. Water is money. The big tanks you see, they represent different parts of the economy, households, the government, businesses. And the flow of colored water between them, that's the flow of money. It's that simple. The model just beautifully shows this core economic idea from the time, something the economist John Maynard Keynes was all about. You have to balance the leakages from the economy with the injections into it. Think of it like a bucket with holes in it. Money is always leaking out of the main flow through things like savings, taxes, and buying imports. But it gets injected back in through investment, government spending, and exports. The whole game is to keep the water level stable. And this is where it gets so cool. It makes the whole concept physical. You want to increase government spending, you literally open a tap. You want to change the tax rate, you just adjust the speed of a pump. It turns these complex, abstract policy decisions into simple, mechanical actions you can see happening in real time. And get this wasn't just some quirky invention for a classroom. Back in its day, the MONIAC was a serious and, believe it or not, a pretty successful tool. I mean, for a gadget made of plastic tubes and tanks, the machine was shockingly accurate. Once they got it calibrated, its calculations were reportedly accurate to within about 2 to 4%. So it wasn't just a visual aid. This thing was a functioning simulator. Yeah, this thing got around, from top universities like Cambridge and Harvard to huge corporations like Ford Motors and even the Central Bank of Guatemala. Somewhere around 12 to 14 MONIACs were built and used all over the world. It just shows you there was this real hunger for a tool that could make these complicated economic relationships tangible and easy to understand. You can just imagine its first demonstration at the London School of Economics back in 1949. The story goes that all these esteemed professors came expecting a total disaster, and instead they saw this mere student, Bill Phillips, put on a masterclass. He completely turned the skeptics into believers, and it basically launched his academic career overnight. But hang on, if it was so brilliant, why aren't we all using water computers today? Well, the answer, of course, was the dawn of the electronic digital computer. Machines like the ENIAC, and yep, the similar name is no coincidence, could crunch numbers with a speed and a precision that a physical, water-based system just couldn't ever hope to match. So in the end, its physical nature was both its greatest strength and its biggest downfall. It was expensive, a real pain to maintain. Sometimes it literally leaked all over the floor, and it just couldn't handle the kind of complexity needed to model things like the unpredictable time delays of economic policies.
But its core idea, man, that was incredibly powerful. This whole approach of modeling the dynamic feedback loops in a complex system, of visualizing stocks and flows, it's now seen as a direct ancestor to the modern field of system dynamics. That's the same science that's used today to model everything from global supply chains to climate change. And it all goes back to this water computer from the 1940s.
But there's a really sharp modern critique of the machine that points out a deeper blind spot. As the economist Kate Raworth notes, the model didn't account for the energy needed to power the economy itself. The Moniac needed an electric pump to keep the water flowing, but that crucial energy source wasn't actually part of the economic model. It's a flaw that, some people argue, continues in a lot of mainstream economics today. This idea of treating the economy like a perpetual motion machine, totally disconnected from the real-world energy and natural resources that actually fuel it.
So here we are in an age of AI and big data. What can we possibly learn from a computer made of water? Well, I think the Moniac is this powerful reminder that clarity is king. It proves that there's just immense value in making invisible systems visible, and that sometimes the best way to understand our complex world is to build a model you can actually touch and just watch the water flow.